But what I want to investigate is how when something's being pushed one way, it can have an invisible opposite force of its own, and that force can get bigger. This is a scrum machine. It's what rugby players use to practice their scrums on. Now, by itself, it's easy enough to push, right, Sarah? Yeah. What happens if we put some weight on it?
How about us?
How much do you two weigh?
About 200 kilos.
I think they do. Let's take a look at this. At the moment, the machine is stationary as there are no forces pushing on either side. Now watch. OK, Sarah? Sarah is pushing with the force of around 300 newtons. But the machine is still stationary. There must be something stopping it moving. A force pushing back against Sarah. It's friction. Friction is a force that's created by these two surfaces rubbing against each other. Now, as the machine isn't moving, we know two things about it. One, it's acting in the opposite direction of the push, and two, it's the same strength as the push. What's going on? Well, on a microscopic level, it's like this. Now, the bottom of the sledge machine may look smooth, but through a microscope, it's uneven, and so is the grass. Now, let's say these studs represent the microscopic view of the uneven surface. Now, when there's no weight on them, they move across the top relatively easily. When there is weight on them, the two uneven surfaces lock and they're harder to move. Now, the machine is gripping the grass just like Sarah's boot. Oh, I forgot to tell them to stop. Sarah, I'm so sorry. Don't worry. I'm going to get you some help. Let's see what happens when we increase the pushing force. Another pusher means the force is now around 600 newtons. Still no movement, so the frictional force must be around 600 newtons too. It's got bigger. With 3 pushers, the force increases to 900 newtons. And so does the frictional force. In fact, it grows at the same rate as pushing force until the force pushing the machine is greater than the frictional force. Well done, team.